Back to my YouTube channel. My name is Mafe Iyinoluwa. Today I'm going to be talking about studying chemistry for beginners. Guess what? I'm now a science student, so I want to share how to study chemistry for beginners or people that are just starting physics like me, science like me. So I'm going to be talking about how studying chemistry for beginners. So the topics I have here with me are introduction to physics, quantities and derived units, motion, and speed and velocity. So let's get started. So now I'll be talking about meaning of physics. According to my own briefing and my own understanding, I believe that physics was naturally called natural philosophy. It is the study of nature that can be understood in a fundamental way, in form of elementary principles and law. What is this talking about? Physics deals with why things are doing. What if I jump? Why did I jump? How did I jump? That's what we're calling. That's what they're talking about. Physics, like it's talking about things that happen in nature that can be understood in a fundamental way, like a form of calculations and principles and laws, like Dalton's law, all those laws. So that's what physics is naturally called. So we all know that physics was naturally called natural philosophy, and the natural philosophy simply means love of knowledge. Like natural philosophy, philo means love of knowledge, something like that. So it can be understood in a fundamental way, in form of elementary principles and laws. So now we are going to be going to reasons and benefits for studying physics. We study physics to acquire knowledge and skills. We'll be able to know more about our environment, and to be able to have skills to calculate some things like electric bulb, the amount of current you are using in your light in an hour, something like that, and to be self-sufficient in our present day society. What does this mean, to be self-sufficient? To be able to carry out some technologies, to be able to build up some things in our present day society, because you all know this world now, this century is made up of technologies. Everything is just technology. So if you are able to be self-sufficient in your present day society, that's that will make you great in life. So physics helps to be self-sufficient in our present day society. We have to have the ability to make our country, perhaps the whole world, a better place to live in. Yes, it is also related to technology, because if you study physics, you'll be able to make the whole world. Like, let us look at Elon Musk now for an example. It is the richest man in the world, due to technologies, building rockets, making a car, Tesla, all those stuffs like that. Is due to physics and some calculations and some things, and it's making the whole world a better place to live in. Now, without Elon Musk's technology, no one can be able to go to Mars or travel out to Mars to know what Mars look like. Like even me, I'm dying to go outside space. I can't wait for 2025 or 2022 to come, to travel out to Mars. So without technologies, one can be able to do that. Without rockets, you can't travel out the earth, you can't go to space. So it helps us to have the ability to make the whole world, perhaps our country, a better place to live in. That's what physics does, and that's all. So now we're going to be going to career opportunity in physics. There are a lot of career opportunities in physics though. We have accelerator physics, acoustic physics, economic physics, communication physics, geophysics, laser physics and technology, and all stuff like that. So there are lots to mention: broadcasting, technology, soldering, and a lot of that. So now we'll be going to fundamental and derived units. Fundamental and derived units. What are fundamental units? We all know that. For people that don't know, fundamental units are the accepted standard units of measurement in which measurement is made. This simply means the units that are accepted by some scientists, the units that are accepted from scientists that can be used to make measurements, like meter as unit of length, meter as unit of length, mass as unit of kilogram, ampere as unit of current, candela as unit of luminous intensity, and Weber as units of magnetic flux, seconds as units of time, and all sorts of that. Those are examples of fundamental units. And now, derived units. Derived units are non-fundamental units derived from fundamental units. This simply means that the calculations, like when you get your final answer from calculations, the answer it gives you, like, let us say, for example, now we have the physical quantity area, the formula which means L times B, and the symbol which means A. We all say the unit is m square, which is meter square, and we all know in fundamental unit, meter is the unit of length. So they are derived from fundamental units. Derived units are derived from fundamental units. They are made by fundamental units. It's derived from the combinations of fundamental units. Like if your area is equals to L times B, or we should say area equals to L times B, and your L is 2 centimeter and your B is 3 your L is 3 centimeter and your B is 2 centimeter. We can say that your area is equals to 6 meters square, because that is the unit. Whenever you've gotten your answer from any calculation in physics, you always try to put the unit if there's a physical quantity there. We can say that if the distance traveled from Lagos to Lekki is 15 kilometers per hour, and the time taken is 30 minutes. What is the speed? You can say we all know that speed is the distance over time, and the formula is v. So we write s equals to s d over t. I think so, because we can say that distance is also the same thing as L. So the speed will be equals to, since distance is L and t represents time, so it will be s, which is speed, is equals to L over c, and which is also equals to was the distance taken, 15 kilometers per hour over 30 minutes. So when you divide it, when you've gotten your answer, then you all know that we are going to write it to be, when you've divided it, let's say 30 divided by 15 to give you 2. So that's going to be 2 meter per second, because that's the unit in speed and velocity. So now we are going to differences between fundamental and derived units. Fundamental units are standard units of measurement, because through the definition we can say that fundamental units are the accepted standard units of measurement in which measurement is made. And while derived units are not standard units of measurement. They are not standard units of measurement because they are derived from fundamental units. We can say that fundamental units are generally acceptable all over the world because it's an accepted standard unit of measurement in which measurement is made. And we can say that derived units are not generally accepted all over the world because they are derived from fundamental units, so they cannot be generally accepted. Fundamental units form the basis of measurements. Through the definition, we said that fundamental units are the accepted standard units of measurement in which measurement is made. So now it's formed the basis of measurements. It's formed measurements because when it's a standard unit of measurement, like meter now. The standard units of measurement, meter is units of length. So they form the basis of measurement. That is what fundamental unit does. But derived units are not they are not the basis of measurement. So we have to note that. So now we are going to fundamental quantities. We all know fundamental quantities are are not the same with fundamental units. Fundamental units are the accepted standard unit of measurement in which measurement is made, and fundamental quantities are those quantities that provide the standard unit of measurement. They are quantities that provide the standard unit of measurement. For example, now, fundamental units are examples of fundamental units are meter as the unit of length, kilogram as the unit of mass. But fundamental quantities include length, mass, time, temperature. I guess what this is trying to do is that since fundamental units are meter as the unit of length, if you write this down, meter as the unit of length, you can say that if you take it from backward, the backward side, because meter as the unit of length, kilogram as the unit of mass, second as the unit of time. If you take it backward, we can say we have length, mass, and time. So that is an example of fundamental quantities. So derived quantities are quantities that are obtained from fundamental quantities in form of combination. So this is where calculation takes place. Since derived units are the units that are not fundamental units or new units derived from fundamental units. Derived quantities too will be derived from fundamental quantities, as we all know. And in the form of calculation, that is the difference between fundamental units and fundamental quantities. Fundamental quantities are like derived quantities and derived units. Derived quantities are like combinations, calculations like multiplication and division, while derived units are like the one of just normal, the units and the formulas and symbols, and that's what they call derived units. So examples of fundamental units out of derived units are velocity, acceleration, momentum, work, power, pressure, area. But we'll soon move to calculations though. So now we are going to motion. Motion. This is where calculation takes place. Motion involves the change of position of body with time. Change of position of body with time. If I'm sitting like this and I change to be sitting like this, it's what we call motion. There's a time taken of when I stand like this and like this. It can be like 1.5 seconds or 1 second. A body is moving. A body is moving in its position with time. A body moves. Like change of position of body with time. If I'm sitting and I'm tired of sitting and I stand up, it is motion because it involves the change of position of body with time. The way I change my body with the time taken, like how many seconds will I use to stand up? I've changed the position of my body and I've already taken the time. So that is motion. The way I stand up is motion. The way you move is motion. So that is what we call motion. And it is the change of position of body with time. So we have type of motion. There are different type of motion. We have random motion, translational motion, rotational motion, and oscillatory or vibratory motion. So random motion are like objects, when objects move irregularly or haphazardly or disorderly without no preferred direction. Like for example, some organisms like amoeba now. Amoeba are example of random motion because they don't move to a specific direction. They move disorderly. Like amoeba is a shapeless organism. So the way it moves doesn't have any direction that is facing through. It can move to this side and other sides without no preferred direction. So it's also known as random motion is also known as Brownian motion. One has to take note of that because it do come out in exams as a tricky question. They can ask that what is Brownian motion, which is also the same thing as random motion, but they just want to trick you. So random motion is also known as Brownian motion. An example is when an irregular motion of particles of various kind suspended in the air, like gas particles suspended in the air. We all know that they don't move through different directions. There are different particles in the air, like oxygen, carbon dioxide, hydrogen, and other stuffs like that. They're in the air and they move without no preferred direction. So that's an example of random motion. Now we have translational motion. Translation motion is when objects, like rigid objects, move from one point to another without rotating. Like example of this translational motion is when a car is moving from Enugu to Lagos and another car is moving from Lagos to Enugu. The car goes from Lagos to Enugu and pick people that are going to Lagos from that Enugu to Lagos. So that's an example of translational motion. Or a bee moving from one flower to another. When it sucks sap from it, it goes to another flower to suck another sap from it, according to biology though. So that is what we call translational motion. So now we have rotational motion. Rotational motion is when an object is moving in a circular form. A typical example of rotational motion is the Earth rotating on its axis, because you all know that the Earth rotates. So it is a typical example of rotational motion. So now we have auxiliary or vibratory motion. This is when object moves to and fro, reversing the direction of its motion and returning regularly to its original position. A typical example of this is a spring. We all know spring. When you press the spring, it goes down and come back to its original position. That's what we call auxiliary or vibratory motion. Like a spring now, we all know if you press a spring, it goes down. That's a motion. It is a change of position of body with time. But this auxiliary motion means it will go back to its original position. Because when we press a spring, we all know that it comes back up. It moves to and fro. So that's an example of auxiliary motion. So next thing we're going to be doing is position, distance, and displacement. Distance can be defined as a total movement of direction without any regard direction. This means that distance can just be defined as the movements of a body within a specific period of space. Like distance means how long you've traveled, how long you've went, how long you've gone far. That's the meaning of distance. But displacement can be defined as the distance traveled in a specific direction. The difference between distance and displacement is that distance doesn't go to any specific direction. Distance can curve like a W, while displacement does go straight a specific direction. We all know that distance are going to a specific direction, but an example of distance is when you're selling something at the back of your house now, so you have to go, and we all know that if you want to calculate the displacement of from where you are to a person selling something at the back of your house, we all know that the distance cannot be more than maybe, let me say, 5 kilometers per hour, 5 kilometers per minute though. But we all know that the distance, we have to go turning before you get to the front of the person's house. But if you want to calculate the displacement, even though there's no direction there, if you want to calculate the displacement straightforward, we can say that the displacement can be 5. It is shorter than the distance covered. The displacement is shorter than the distance covered. So that's the difference between displacement and distance. An example of displacement is if a boy walks 30 meters eastward and then 40 meters northward, his displacement is 50 meters in a northeast direction. So I'm going to be solving why his displacement is 50 meters in the northeast direction. If you are drawing a table of something like this, you are drawing a table of something like this. This is the northward. The question is, if a boy walks 30 meters eastward, so this is 30 meters eastward, this is eastward, with the table of north, south, and east, north, east, south, and west. You all know the north is like a cross from north, south, east, and west. You all know. So you can see that this is the north. This is the north here. Your body travels 30 meter eastward, and then 50 meter, and then 40 meter northward. So this is 40 meter northward and 30 meter eastward. So let's calculate the displacement. We all know Pythagoras theorem, right? Which is hypotenuse square equals to opposite square plus adjacent square. So we all know that we are looking for the hypotenuse according to the angle of the diagram shown to you. This diagram here, we are looking for this place because this is northward and eastward. So now we are looking for this place. So we all know hypotenuse equals to opposite over adjacent square. So that's x square, which is this place that we don't know, the unknown number, minus 40 square, which is the northward, northward, plus 30 square, which is eastward. So when we add it together with the square, we get 16,000 plus 9,000, which is 25,000. So the square root of 29,000 is 50 meter. So now, this example is displacement is 50 meter northeast. How is the displacement 50 meter northeast? This is how its displacement is 50 meter northeast. Yeah, 50 meter northeast. So this type of calculation is what we call displacement. So this is, but an example of distance is something like this. It doesn't have a specific direction. You turn and turn and turn till you get to your direction, which is longer than the normal displacement. So the last thing we are going to be doing is speed and velocity. Speed can be defined as the rate at which a body covers a distance. And we all know that in my previous explanation, formula for speed is distance over time, which is also known as L over T or S over T. So we have types of speed. We have uniform speed. Uniform speed is when a body covers equal distance with equal time intervals, no matter how small the time interval may be. This means that when you are, a typical example of this is this diagram shown to you. You can see that the speed taken is the same speed with the equal time interval, like 10 meter length. Let us take an example of this diagram of the length 10 meter. And let us say that from the point of the starting point to the first lap, the person takes 3 seconds. To the second lap, 3 seconds. And to the third lap, 3 seconds. So that is what we call uniform speed and velocity. So velocity can be defined as when velocity is the rate of change of displacement. It is kind of similar to speed, but this is the rate of change of displacement, like how the displacement changes. No, displacement is the change a body covers distance with time or so. So displacement, the velocity is the rate of change of displacement. Displacement is the distance traveled in a specific direction, while velocity is the rate of change of displacement. And the formula for velocity is displacement over time, which is also known as V equals to S over T. So uniform velocity is also when a body moves with equal displacement in equal time intervals. And uniform velocity, you all know it is the opposite of uniform velocity. So that's all for today, guys, and I hope you understood everything I've said. And don't forget to like, comment, share, and subscribe on this video. If you don't understand anything there, you can comment and can go back again to explain better for you. Thank you. Bye.